One more chain rule for your help. So we're going to determine the gradient of y equals x squared plus 3x plus 2 all to the power of 2 at the points where the graph meets the x-axis. So we've got a bit of work to do. First thing is to determine the gradient of the function using the chain rule. So if we wanted to do this, well, we just apply the chain rule. So dy dx is equal to dy du du dx. Alrighty? And in this case, y is equal to u squared and u is equal to x squared plus 3x plus 2. dy du is equal to 2u and du dx is equal to 2x plus 3. We don't write u as u, we rewrite u as 2x squared plus 3x plus 2. Now we can just do our substitution straight in, and we get 2x squared plus 3x plus 2 times 2x plus 3. Need a bit more space. Alright, so finishing up the substitution. Alright, and we should probably clean this up a little bit. So let's expand the brackets first. X squared times 2x is 2x to the 3. X squared times 3 is 3x squared. 3x times 2x is 6x squared. 3x times 3 is 9x. 2 times 2x is 4x. And 2 times 3 is 6. Collect the like terms. We've got 3x squared plus 6x squared, that's 9x squared. And we've got 9x plus 4x, which is 13x plus 6. Expand the outer brackets, and we get 4x to the 3, 18x squared, 26x, and 12. Alrighty. So in this case, we did need to expand the brackets just to make it all a little bit simpler. Alrighty. So then it asks us to determine the gradient of this function at the points where its graph meets the x-axis. Alrighty. So when things meet the x-axis, that means when y is equal to 0. And so we're not solving on our gradient function yet, we're actually solving on the original function. Alright, now in order to solve this, it's always good to factorize things further. So let's factorize the inner. Alrighty, it's got 2. We're going to have, it's just a monic. So things that multiply together to 2 adds to 3 must be positive 1 and positive 2. 1 times 2 is 2. 1 plus 2 is 3. So that works out perfectly. And all of this is being squared. However, by null factor law, if this whole thing is going to be equal to there, then either this has got to be e equal to 0, or this is going to be equal to 0. And so we've got our two solutions of x equals negative 1 and x equals negative 2. And let's sub both of these into our gradient function. So let's do that. When x is equal to negative 1, then dy du dx, the derivative is equal to 4, negative 1 to the 3, 18, negative 1 squared, plus 26, negative 1 plus 12. So we get negative 4 plus 18, negative 26 plus 12, which adds up to 0. And then let's also solve at x equals negative 2. Same operation, dy dx, negative 2 to the 3, 18, negative 2 to this 2, 26, negative 2 plus 12. We get negative 32. Negative 2 squared is 4. 4 times 18, 72. 26 times negative 2 is minus 52 plus 12. And once again, this also adds up to 0. Alrighty, so there we go. We have used the chain rule to find where the gradient at the points where it meets the x-axis. And in this case, we found out that the gradient at both of these points is 0. Alrighty, if you want, you can check my working out by graphing that function and seeing what it looks like. Alrighty, I'll see you in the next one. Bye.